This lesson is going to be about like terms. Our learning objectives are to know what like terms are, to be able to identify like terms within an expression, to be able to simplify expressions by combining like terms, and finally, to be able to combine like terms to find equivalent expressions. I'm going to start this lesson by telling you a story. So one day I went to the supermarket to buy some chocolate. So I went to the chocolate aisle and I bought 2 blocks of chocolate and 3 Mars bars, and then I headed to the cash registers. Now I want everyone to picture what cash registers look like at a supermarket. What does every supermarket put near the cash registers? That's right, more chocolate. And that's because the supermarket is hoping you make an impulse buy before you have to pay. Now, unfortunately, when it comes to chocolate, I have no self-control. So while I was standing in the line at the cash register, I picked up 3 more blocks of chocolate and 5 more Mars bars. Now, after I had paid, I looked at the receipt, and the receipt did not say that I bought 2 blocks of chocolate and 3 Mars bars and 3 blocks of chocolate and 5 Mars bars. Rather, it simply said that I had bought 5 blocks of chocolate and 8 Mars bars. Now, this is what we call in algebra simplifying an expression by combining like terms. So I took this expression over here and I simplified it by combining like terms. So this over here is my simplified form of this expression. So in this lesson, we're going to be learning what it means to simplify an expression by combining like terms. So what does it mean by like terms? Well, hopefully it's all pretty intuitive by looking at this example. Obviously, when I have blocks of chocolate and blocks of chocolate, I can add these together. So 2 plus 3 is 5. And that's how I got this 5 right here. So too, I got both of my Mars bars. I have 3 Mars bars over here. I have 5 Mars bars over here. And I plus them together and I got 8 Mars bars. So what we could say is that these right here are like terms. And so too this and these are like terms. But now I want to show you another example, but using our common algebraic notation when doing so. So that means our pronumerals this time are going to be our letters, and I've chosen x and y. But notice the fact that my coefficients, so 2 in this case, or 3 and 5, they're all the same. So all I've really done is swapped out my chocolate for letters. That's all I've really done when I've rewritten this expression down here. Now let's go over some terminology that we learned in our previous lessons. We know that this right here, this is a term. This is a term, this is a term, this is a term. I don't have to write them in for every one of them, but you know that each of these is a term. So I could say that this expression is made up of 1, 2, 3, 4 terms. I know that this 2, this 3, and this 5, they're all coefficients. So remember, a coefficient is simply the number in front of the pronumeral. And lastly, and most importantly for this topic, we know that this pronumeral, or this letter right here, is a pronumeral. A pronumeral. This y is a pronumeral, this x is a pronumeral, this y is a pronumeral. And when we're dealing with like terms, the pronumeral is very important. So what we're going to say is whenever I have a term that has exactly the same pronumeral, so in this case, I have 2x and I have 3x. So as you can see, my pronumeral in both cases are the same. So this is my pronumeral, the x, pronumeral. This x, both of these terms have the same pronumeral. So therefore, I can combine them. So I'm going to go 2x plus 3x is 5x. So too, I can get my other pen now. I see I have 3y and I have a y here. Both of these terms, 3y and 5y, both of these terms have the same pronumeral, y. So that means I can combine them together. So that means my answer is going to be plus 3 plus 5 is 8y. Notice that this is exactly what we did up here, but I've simply brought in our normal terminology of pronumerals, but the same idea holds true. So hopefully this has really helped you understand what I mean when I'm going to talk about like terms in this lesson. So let's now go through some formal definitions. Like terms are terms containing exactly the same pronumerals, although not necessarily in the same order. So right here we have 5ab and 3ab, and they are like terms. And the reason why they're like terms is because my pronumerals ab are the same. Down here we have 4a and 7b are not like terms. Now the reason why they're not like terms is because I have a pronumeral of a and a pronumeral of b, and because they're different pronumerals, they are not like terms. Finally, we have 2acb and 4BAC, and these are like terms. And the reason why they're like terms is because they have the same pronumerals A, B, B, and C. Over here, I have A, B, and C. They're just not in the same order. And that's what my definition says here, that they have exactly the same pronumerals, although not necessarily in the same order. Let's continue to read. Like terms can be combined with an expression to create a simpler expression that is equivalent. For example, 4AB plus 3AB can be simplified to 8AB. And this is what we saw in our chocolate example. We are combining our like terms together. So 5AB plus 3AB is 8AB. And what we're creating is equivalent expressions. And we're going to talk more about that later, but we've encountered this word before. Lastly, if two terms are not like terms, such as 4x and 5y, and remember, these aren't like terms because the pronumerals are different. So if two terms are not like terms, they can still be added to get an expression like 4x plus 5y, but this expression cannot be simplified further. So it has to stay like that. I can't combine them together because they're not like terms. So we just leave it like that. Now, I want to make sure that everyone remembers this definition. Like terms are terms containing exactly the same pronumerals, although not necessarily in the same order. Now, keeping that in our mind, let's now go through an example. So classify the following pairs as like terms or not like terms. So here's our first example, 3x and 2x. Well, because they have exactly the same pronumeral, they are like terms. So I can get my pen and I can say, yes, they are like terms. And I could even say, because they have the same pronumeral, which in this case is x. Perfect. Let's go to our next question, which is 3a and 3b. Now, these are not like terms, and the reason for that is because my pronumerals a and b are different. So I'm going to get my red pen and I'm going to say no. And if you wanted to, down here, you could write because they have different pronumerals. A and B. Let's now go over our last example, which is 2AB and 5BA. Now, this question is supposed to trick you because AB and BA are the same pronumerals, just in different order. Now, if we remember back to what our definitions are, like terms are terms containing exactly the same pronumerals, although not necessarily in the same order. So here we have AB, we have AB, but over here it's just in a different order. So the answer to this is yes. And you're going to say down here, because they have the same pronumerals. Even though they are in a different order. Now let's reflect on why this is the case. AB and BA are the same because of our commutative property of multiplication. Remember, even though there isn't a multiplication sign there, this A and this B, they are multiplying together. And we know that A times B is the same as B times A. So even though that the order is different, we know that they're expressing the same answer, AB equals BA. And that's the commutative property of multiplication. The order doesn't matter. I now want you to pause the video and answer these questions for yourself. Just give me a yes or no for each one. So pause the video, good luck. So how did you go with these questions? What you needed to do was classify the following pairs as like terms or not like terms. So the first one we have here is 4K and K. Now, the very first thing that we need to remember is that we have 4K here and we have K. Now, remember that there's an invisible 1 in front of that K, which just means we have 1K, but we don't put in this 1. So that's very important for you to know. But that really wasn't relevant to what the question was asking, because remember, we're looking for like terms, so we're trying to figure out whether or not I have the same pronumeral. And K, well, they're the same, so my answer for the first one is going to be yes. Let's now answer the second question, which has 2A and 4AB. Now remember, for them to be like terms, they have to have the same pronumerals. Now A and A, B, they are not the same pronumerals. A does not equal A, B. They're not the same. So for the second question here, you should have written no. Let's now go into the third one where the same logic is going to apply. I have 7AB, and then over here I have 9ABA. Now obviously ABA is not the same as AB. I have an extra A here. So these are not like terms because my pronumerals are different. So you should have written no right there. Hopefully you got all of those correct. Let's now move on to our next example, which is asking us to simplify the following by collecting like terms. Now, before we begin answering these questions, I want you to underline the word collecting because you might see other words other than collecting. So another word you might see is combining, and you might also see gathering. My favorite word is gathering. I like gathering the best. But all of these words, gathering, combining, collecting, they all mean the same thing. To bring to one spot. If you're collecting something, you're bringing them all to one spot. If you're combining, you're bringing them all to one spot. If you're gathering, you're bringing them all to one spot. They all mean the same things. So you shouldn't be confused if a question in the future uses gathering or combining. So let's now answer the question. So let's now answer this question. We have 13a plus 8b plus 2a minus 5b minus 4a. Now remember, what we're trying to do is simplify the following by collecting like terms. So let me begin by highlighting my like terms. I have 13a, I have plus 2a, and I have minus 4a. I know that all of these are like terms because they share the same pronumeral a. Let me now get another highlighter and highlight plus 8b minus 5b. And again, I know that these are like terms because they have the same pronumeral, b. My next step is now going to be collecting the like terms. So what I'm going to first do is simply write all my like terms next to each other. So I'm simply going to change my order. So I'm going to write 13a, and now I'm going to write plus 2a next to it. And then next to that, I'm going to write minus 4a. And now that I've finished with all the a pronumerals, I'm now going to move on to my b's. So I'm going to write 8b, then minus 5b. Now, it's very important that we appreciate the fact and realize that this is absolutely crucial, that I kept the sign in front of my number the same. So as you can see here, I have plus 2a, and that's because there is a plus in front of my 2a. So too, over here, we have minus 4a, and that's because there is a minus in front of my 4a. So the only way you can get the correct answer is making sure that you keep the sign in front of the number the same. That is absolutely crucial. So now that I've changed the order around, now I can really collect them together. So I know that 13a plus 2a, well, that's 15a, minus 4a, that is 11a. And over here, I'm going to have plus 8b minus 5b, well, 8 minus 5, that's 3, so I'm going to get plus 3b. So my answer is going to be 11a plus 3b. So I'm going to get a green, and I'm going to put a box around that. Now we're going to talk about this later, but it's also important to realize that 11a plus 3b is an equivalent expression to 13a plus 8b plus 2a minus 5b minus 4a. This and this are equivalent expressions, meaning if I was to sub in the same values for a and the same values for b into both of these, I would get out the same answer. We're going to see that more further on. Let's now answer this next question together. We have 5 plus 12 plus 4b minus 2 minus 3a. So what I'm trying to do is simplify the following by collecting all the like terms. So let's first identify all the like terms that I have. So I have minus 3a. Does that have any like terms here? Well, it doesn't because I don't have any other terms with the pronumeral a. So that's the only one I have. Well, what about plus 4b? Well, yet again, b doesn't appear anywhere else. I don't have any other terms with the pronumeral b. So there aren't any like terms for it. Now, hopefully you can see that I have 5 and plus 12 and minus 2. Now, we gave these a special word in our previous lessons. We call these constants, and we can gather the constants together. So what I can do is go, I know that 5 plus 12 is 17, and 17 minus 2, that's 15. So what I've done is I've gathered together the constants, and then I just need to leave these as they are. So plus 4b minus 3a, there's nothing I can do with those. I simply need to leave it like this. So really the trick to answering this question right here is realizing that you can just plus together normal numbers, which is kind of an obvious statement. So that's important that you realize that in algebra, just as you can gather like terms like 4a and 2a and 13a, you can gather together constants as well. So in other words, you can plus together normal numbers, something that you've been doing for a long time now in maths. So I'm going to give this a green box because that's the correct answer. Let's now move on to our next example, which is asking us to simplify the following by collecting like terms. This time it's your turn, so I want you to pause the video and see if you can answer these questions. Good luck. All right, I'm going to quickly answer these questions for you. So the first thing that I'm going to do is find out which of these are like terms. So I have 10uv, and then over here I have minus tvu. Remember that these are both like terms, even though that my pronumerals are in different order. That doesn't matter. As long as they're both the same, they're still like terms. Let's see if I have any other. I have plus 3u, and over here I have plus 7u. And then I have plus 2v. That doesn't have any like terms, so that's by itself. The next thing I want to do is gather my like terms. Now I could write them next to each other first, or I could go straight in and just write down the answer. So 10uv minus 2vu, well, that is going to be 8, because 10 minus 2 is 8, and then I need to make sure that I put my correct pronumerals. Now I could have written that as vu, but I wanted to write uv. Okay, next I have plus 3u plus 7u, so 3 plus 7 is 10, so I'm going to get plus 10u, and make sure that looks like a u. And then lastly I have plus 2v. There's nothing to gather that with, so that is just 10, that is just plus 2v. So that is your answer to the first one. Hopefully you got that correct. Let's now move on to our second question, which is 9a plus 4b minus 3a minus 3b plus a. Once again, let's highlight all our like terms. So that's all the terms with the same pronumeral. So here I have 9a minus 3a plus a, so all a's. Next, I have my b's plus 4b and minus 3b. So now that I can see which are my like terms, I'm now going to combine them together. So 9a minus 3a, that's 6a, plus a is going to be 7a. 7a. So all I did there was 9 minus 3 is 6, plus 1 is 7. So remember there's an invisible 1 in front of that. Then we have plus 4b minus 3b. 4 minus 3, that's going to be 1. So it's going to be plus b. Now, I don't want anyone to put a 1 in front of that b. That 1 is invisible. You should not write it. Just as there is an invisible 1 there, there's going to be an invisible 1 there. But remember that as we get older now, we like to do certain things in maths, and one of those is not putting 1 as a coefficient in algebra. We just leave it as that. So hopefully you got both of those correct. The last thing I want to talk about is gathering like terms to find equivalent expressions. So we talked about this in our last lesson. We talked about equivalent expressions, and we found out if expressions were equivalent by substitution in that last lesson. But we can also figure out if expressions are equivalent by gathering like terms. So here we have the question, pick the two expressions which are equivalent. So here we have 5x minus 2, 2x plus 3x plus 2. Well, immediately I can see like terms, 2x and plus 3x. I can gather those together. 2 plus 3 is 5, and I've got that x there, and plus 2. And remember over here, let me just write this down as well. And then finally over here we have 3x minus 2 plus 2x. Well, I have a 3x and I have a plus 2x. These are like terms, so let me gather them together. 3 plus 2 again is 5x, and I have this minus 2 as well, minus 2. So now if we look at this, it's quite clear that 5x minus 2 is the same thing as 5x minus 2. So by gathering the like terms, we've discovered that this and this expression are equivalent. I now want you to try this out for yourself, so pause the video and see if you can pick the two expressions which are equivalent. Pause the video and give it a go. So let's now quickly run through these questions. So we have 4t and 2t plus 4 and t plus 4 plus t. So let me just write them out. We have 4t. Then over here we have 2t plus 4. Then over here I have t, I have t. Well, these are like terms. These and this are like terms. And remember that there's an invisible 1 in front of both of them. So 1 plus 1 is 2. So I'm going to get 2t plus 4. Now, it's quite clear that this is the same as this. So therefore, this and this are equivalent expressions. Let's now do the next question, in which I have h plus h plus h. Then I have 4h, and then I have 5h minus 2h. Now, h plus h, all of these are like terms. H and h and h, they're all like terms. So that is 3h. This over here is 4h. And this over here, well, I have 5h and I have minus 2h. Both of these are like terms. So I can go 5 minus 2, that is 3h. And therefore, we can see that 3h, they're the same. So therefore, this and this are equivalent expressions. So hopefully you got both of those correct. Let's now review what we've learnt in this lesson, which has been about like terms. Our learning objectives were to know what like terms are. So could you give me a definition of like terms? Next, to be able to identify like terms within an expression. So if I was to give you an expression, could you point out which were the like terms? Next, to be able to simplify expressions by combining like terms. Hopefully you're able to do that. And finally, to be able to combine like terms to find equivalent expressions. So that's the very last thing we went through. So hopefully you're able to do all these 4 things that we've gone through in this lesson. Hopefully this lesson's been helpful to you. Make sure now to complete your homework.